This is Kamala Grace from Department of IT, GRIT College. Today, me and my teammates are gonna present you our mini project, Prevent Detection of Electricity Theft in Smart Grids using Deep Neural Networks. Under the guidance of V. Saraja ma'am, our assistant professor, me and my teammates have built this project. This presentation contains the abstract, existing systems, proposed systems, system specifications, design, system architecture, source code, test cases, and conclusion. My teammate Monica is going to tell you about the abstract of her project.
Coming to the abstract of our project, electricity theft is a worldwide global problem in developing nations. It has an adverse impact on utility providers as well as power consumers. It affects the high cost of energy for consumers, creates electrical dangers, and admires the financial growth of utility firms. The development of smart grids has a significance on the detection of power theft. Since this system provides vast amount of data, including power consumption data and the use of the data, we developed this model using deep neural networks. We used XGBoost algorithms, SVM, and we used PCA for feature extraction. Coming to the existing systems of the project, the existing systems detect electricity theft primarily rely on hardware-based methodologies, while this takes more time. Since we developed this model to reduce the time for detecting the electricity theft, the proposed system will be explained by Kamala Grace.
So, we have used the DNN classification method for detecting the electricity theft as it enhances the performance and the domain features frequency. And the feature selection method, the principal component analysis, is used in this project as it gives us the minimum redundancy and maximum relevance, and it highlights the importance of frequency domain features for effective detection of electricity theft. The optimization of hyperparameters using Bayesian optimizer and adaptive movement estimation. Optimizer enhances overall performance and training speed. So the availability of large data sets from cloud providers and other business facilitates effective training of DNNs. Now, the system specifications are given here, and the basic for the Windows 7 and the coding language is Python, and the database is taken from MySQL, and the hardware specifications are Intel i5, hard disk of 120 GB, and monitor of 15-inch, and RAM of minimum 4 GB. The design will be explained by Saujanya.
The design of our project mainly described in 4 diagrams: use case diagram, class diagram, sequence diagram, and activity diagram. Firstly, I'll explain about use case diagram. Here we use 2 actors. One is remote user and the second is service provider. And both actors will undergo some of the following steps: train and test electricity data sets, view electricity data sets, and view accuracy, registration and login, and predicting electricity theft type and the accuracy. And next goes to class diagram. Class diagram, we have used mainly 4 classes. One is for service provider, other is for login and register and remote user. And the third one is sequence diagram. In sequence diagram, we have 3 main components: remote user, web server, and service provider. And the last is activity diagram. This is the flow of some of the activities that we undergo in our project. And nextly, I'll go to describe about the system architecture. These are the following steps that we undergo in our system architecture. First, we start with the data collection. Here we use HCCC data, which contains many inconsistencies and redundancy. Some of the data pre-processing techniques like PCA and LDA are used to extract the important features and remove all the missing data. And for data balancing, we used IQMOT data balancing techniques. For one-dimensional data, we use LSTM, short long-term memory, and for two-dimensional data, we used unit feature extraction. After completion of the successful data balancing, for training our data, we use the ADA Boost optimizer technique, where all the important features are extracted and we perform our respective tasks. And for the performance evaluation, we use the confusion matrix. There are 4 limitations that we mainly addressed in our project. And the first one is data imbalance, where we used IQMOT, a very high technology to balance our data set. And the second is high dimensional data and feature extraction. And the third limitation is we used mainly sigmoid and softmax activation function to detect our electricity theft. And the fourth is loss of features localization information. And the next is about source code. The source code of our project mainly includes URLs. Here we use the Django platform to develop our database and to perform our actions. These are the following URLs that are used in our Django. Mainly register, predict financial type, view your profile, service provider login, view remote users, charts. Train models are the URLs. And the next is dataset creation in Django. This is the syntaxes and the statements that are used to write or create the dataset in the Django platform. And the next is views. Coming to the views, we have some of the methods like service provider login method, view financial type ratio method, and the next is view remote user method, view renderings, charts. These are the following methods. And the next is training the model. For training the model, we mainly use some of the techniques, SVM and logistic regressions and decision tree classifiers are used on our model. And the last is accuracy prediction with various algorithms. We, for accuracy measurements or performance evaluation, we used confusion matrix and classification reports. And for the outlook of our page, for login.html, we created the login.html web page. And for registration, we use register.html. This is our registration page, where the server should enter the username, email address, password, mobile number, country, state, and city. The valid after clicking the registration, after successful registration, we then directed to login page, where we have to enter the username and password. After providing valid details, click on service provider. This is the page where we have to enter all the relevant data regarding the customer to know whether the data is electricity is theft or not. After entering the valid details and click on predict, then the result will be displayed at the bottom right corner. If it is theft, it is detected like theft. If it is no theft, result will be displayed. For accuracy on training, we used SVM, logistic regression, and decision tree classifiers. These are the accuracy results of 3 algorithms. And this is the pie chart representation of our theft and no theft results. And for accuracy prediction, we use bar chart representation and line representation. And these are the test case scenarios. There are 6 scenarios for our project. The first is registration. If we, after entering the valid inputs, if the registration is successful, we then go to the login page. If the registration is unsuccessful, then a error message will be displayed like user should be registered unsuccessfully. After entering to the login functionality, if the valid in username and password is valid, then we go to the server provider page. If it is invalid, then error message will be displayed like user should be logged in unsuccessfully. After entering the valid details in the service provider page, we came to know whether the customer is theft or untheft. The conclusion and future enhancements in our project mainly describes about the DNN-based classification approach, where we used both time domain and feature domain features. The isolated time domain and feature domain gives a maximum accuracy and prediction results. From the test page, our classifier achieved 87.3 accuracy and 93% AUC ROC curve. And we mainly used 7 components out of 20 components, which are very much important for our project. A well-known popular Bayesian optimizer was used for optimizing hyperparameters, which plays an important role. And thank you.